Okay, we can build on what we've been doing before by actually making sense out of this relationship. Y, we've said it was something times x plus or minus something else. Well, the something that's times x is m, and plus something else is c or b, and we will most often use c. So in this case, m is the gradient. That's how much y changes. Just when we had those tables where x changed by 1, how much does y change? That's going to be our gradient, or m. And c is the y-intercept, or exactly the point where, when x is 0, here it is, y is negative 1. So in this case, we've worked out between these 2 points that the gradient, which is, of course, the rise over the run, the gradient rises up 2 over the run of 1. So our gradient is 2, or 2 over 1. And right here, when x is 0, y is that point there at negative 1. So along this, when x is 0, anywhere along here, where do we get the intercept? Aha, at negative 0. So that makes our constant negative 1. So if we take our formula, y equals mx plus 1, the gradient is 2, and I'm going to add to it negative 1, which of course we know means we're going to subtract 1. So y equals 2x minus 1. That explains, that's the rule for that graph. Now sometimes you'll have a plain old horizontal line that goes straight across. Well, it doesn't actually have any, if I use the formula, it has a gradient of 0. Gosh, it has a gradient of 0, so if I worked it out, I'd have a gradient of 0 times x, so it doesn't matter anymore. So we're just going to actually say, jump straight to y equals c. So in this case, y equals that constant. Here, where x is 0, y is 5, y equals 5. Here, where x is 0, here's that point, then y equals negative 4, so y equals negative 4. When we have a vertical line like this, which is undefined, we're just going to say x is equal to that point on the line where it crosses, because up and down y can be anything. You know, whether or not y is 1 or 2 or 3 or 4 or negative something or other, we're going to be right here on negative 2. And y can change to anything because it's undefined. And the same thing here if we looked at this one. At this point, we've moved along where x is 4 and y is 0. Well, it's still going to be 4 anywhere along this line, whether y is a billion to negative a billion. So we just jump right to x is equal to 4, no matter what y is. Now, before we don't want to solve these, we just want to find out what's the gradient and the y-intercept. And that's really important because that's how these linear relationships work. I'll look up here again. This is where the gradient is going to turn up, or the change in y. And this is going to be the y-intercept, or where that line crosses the y-axis. So all I have to do is look at these, and I see here that that is in the place of m, because y equals gradient times x plus the constant. So in this case, the gradient is equal to 2. And my constant, which is the y-intercept, is positive 3, or just 3. In this one over here, using the same rule, y equals gradient times x plus the y-intercept. I can see here that I've got 1/3, so I'm just going to go right to the gradient is 1 over 3, rise over the run. And you can see here I've got a negative 4, so I'm going to keep that together, and c is actually going to cross over that line. When x is 0, we're going to cross the y-axis at negative 4. Now we're going to find out the whole thing. We're going to find the rule, and our general rule is y equals gradient times x plus the y-intercept. We got to find the values of m and the y-intercept. So we've got a graph. You can take any points that actually intersect a line, so they're actually whole numbers, so we know we got them right. And so first I'm going to find the gradient. The gradient is the rise over the run, and in this case, between these 2 points, I'm going 1, 2, 3, 4. I'm rising 4, because it's going up from left to right, across the space of 1. So m is going to equal 4. And now where do we cross the y line? All we have to do is find that point. Here it is. In fact, it's just given to us. So in this case, I'll just scroll down a tiny bit. Our constant equals negative 1. Because when x is 0, right here on this line, that's where we cross y. So our rule is going to be mx plus c. I'm going to replace m with 4 because that's our gradient. And I'm going to replace plus c with minus 1 because we're adding negative 1. Same deal over here, but this time our rise is negative 4. M equals the rise over the run. So this case, our rise is 4. So we're going negative 4, rather, over a distance of 2. So that reduces to negative 2 over 1, or negative 2. So our gradient is actually going to be negative. And where does it cross the y line? Well, that's way up here. When x is 0, y equals 4. So that gives us, we use our rule. We replace m with negative 2, and we replace c with 4, and that gives us our rule. To find the rule for these horizontal lines, well, we know that y equals gradient x plus wherever we intercept y, and we're intercepting y here at negative 3. So I can have, this is a gradient of 0 because it doesn't go up at all, plus negative 3. I don't need to worry about that. In fact, I can just skip that whole part of the equation because it's going to zero out. Y equals c. And that's why we get y equals negative 3. For this one, we just look at where x is along the graph, and we look at where this is x and this is y. The rule for this is just going to be wherever y is 0, the value for x, which we call k. So x equals that value where y is 0. Have fun.